Hi, today we will discuss the problem which is called minimum window substring. And this is the definition of this problem. Given a string S and a string T, finds the minimum window in S which will contain all the characters in T in complexity O of n. Example, if you're an example here, so S looks like this. This is the string, the biggest one, and here it is the smallest one string, and we have to find these all letters. For example, we have to find this A, so it's here, here, B, here, and C. And we have to find only one window where the smallest string which contains these all numbers. So that is here. Have B, have A, and have C. Usually for B here, for example, are the A, so we have to find double A here, so this will be here. So we have double A, B, we have two, but we don't need it, and C. Yes, it will be something like this. Okay, so how to solve it? First, the best way to solve it is to build a window. And how to build this window? We are starting from we are starting for A. We adding the one letter here, and we check if we have this letter here. On the beginning, I have forgotten. You have to prepare a hash table from this. Here's the solution. I can show you here. Oh yes, this is the dictionary. So this is hash table made from this ABC, and you have a character and the int how many times this character appeared in this string. Okay, so we have this in our window only A. We check in this our dictionary if there is A. If it is, then we have this value count, and we increase this count because we have found a letter which is in our dictionary. If this count is equal required, and the value which is const, if they are the same, then we have found the window. If it isn't, we don't have found the window which contained all these characters. So first, yes, we have this A, and our count is 1, and have to be 3. Yeah, we carry this 3. Okay, so we're going further. D, so we have this window, and D we don't have here, so we go further. So we got O, we don't have there, so we go further. We expand our window to B, and B we have in our dictionary. The count will be 2. Yes, and then we go further because this is not 3. B, A, we don't have A, but C. Okay, C we have, so the count will be 3. So this is the same like required. We have find this window, and we save this like an answer, the size of this window. But we go further, and we are looking the smaller window contain all these characters. What we are doing? We are reduce the size of this window from the beginning. For example, we reduce this A, and we have window like this. If we reduce the number, first we are looking this letter in the dictionary. If there is a here's in the dictionary, we remove this count. We now remove, decrease the count. So our count will be 2. It's not 3, so we can't save this answer. Then remove the next one. Sorry. Oh, if we have the count less than our required, we expand our window further. So we have here O. Oh no, it doesn't increase our account, so we go further, D, and then A, and B. B we have in our dictionary, but we have it not the same amount. This is the place here in our solution. Okay, so if we found this is our character C, so this is our B here. We have here a moment. We can consider this. So we have this character B here. B is in our dictionary, but we also use the same number of the same number of our letters, so the same amount of our letters, and only in this case we increase count, because we have one B, and this amount of this B will be in our dictionary 1, and here 2. It's not equal, so we don't increase, so we have still 2. We don't have 3. So we go further, and this then A, and A we have found now in dictionary, and the same amount. We have 1A here and 1A here. We increase, so then we have our count 3. It is the same like required, so we save this window. If we save this window, like answer, it is smaller than the previous one. We save it, but actually this is larger. And then here's another loop where we reduce this window. So this will start here to this. D isn't in our dictionary, so we don't reduce it. So we have still 3. O, and we have here B. O, B, and then we want to this B reduce. So where we have it, we have it like here. So we have this B, okay, but we have something like this here. We have rid of B here, but we have double B here. So this dictionary, yes, B is in our dictionary, but the amount of in our dictionary, it have to be larger than in our window. In our window we have 1, and in our dictionary we have also 1. So it is not it's equal, it's not bigger, so this will not perform. So the count will be still 3. So we had this good, have all this letter. Okay, so you have here we have rid of the B, then the C, the A, so the E, then we have here C, and if we here, if we're rid of a C, we have to go further here. So then we go n, from O to n. It's nothing, and we see, yes, we have our dictionary, the count will be 3, and then we reduce O, D, B here, and if we have this, and all the time we save this answer when we have all characters, so we save this answer, we have save this answer, but only remember and save if the size is the smallest. Okay, so we have B and C, and we save this answer, and then we reduce to A and B. And now we don't save this answer, but we save this because there was the smallest window, the size of the window. Okay. This is so simple. I can show you here the whole solution here. Is the function which have s and t. If the size is 0, the return, because in this case will be the best option. We make this dictionary. I have this in a function here. So I go through the whole string and add in the dictionary. This is an ordered map with char and int. Okay, here we have the dictionary. We have here two indexes which increase our window and decrease. So on the left side we decrease our window, on the right side we increase expand our window. The answer, the structure which we save our answer, this is size and left. And how many size here and where it started. Okay. Only one function which get left and right, and then we save it like here. Okay, so we have this answer. We have here the hash table with the window. I call it window interior, and count and required. How many? So we have the loop. If the right is smaller than the size, you can go more than the size of this. Then we have this char, and we get this char from this string, from this index. We increase our window because we are adding this char to our window, and check if this is in our dictionary and if the amount is the same. If it is the same, for example, we have here 2a, you only have found 1, this is not the same, this will not increase. If we have found 2a, that's the same, and then we will increase. If we have found 3a, then it's not the same, this is not increase. Okay, and then we have check if we have this count the same like required, and also if the left isn't bigger than the right, because yes, this will be, we can only have one letter here. So if it's 0, the right have to be also 0, there will be one letter. Okay, here if the size isn't 0, because on the beginning we have 0 here, no, here, size here, check if this is not the first one, our attempts to answer. And then if we check the size, if the size is smaller, so we save this answer. If not, we don't save this answer. And then we take this, for example, this window, we take this letter A here and read off from our window. Then we check if this was in the dictionary. Okay, if this number was that have the same amount, no, bigger amount than in our window interior. It was the same like I explained it before. So for example, we have here 1A, and here we have 3 in here. Then we will not decrease it because we have still 1A which we needed. If we have the same amount, it's also okay. We don't decrease it because we have removed it, so this still have enough amount of this letter. Okay, and then we go from the left to the next one, and it works like this. Okay, on the and we check if we have size 0, so we didn't have found anything, and then we do this, and we make a string from this from the left and the size. Yes. Okay, and this have also one optimization can have. I can show you. This is like the idea is not to check all string, check only the letter which are in our dictionary. So rid of the D, O, B, B, no, we leave A, V, moment. Yes, this we delete, this will be delete, and this will be something like this. And we remember where this was in the previous string. Here was on the index 0, this was on the index, I don't know, I have to count. 1, 2, 3. This was on index 3, and so on, so on. And we make this vector or list which have 2. I can show you, maybe this will be better. Okay, so we have it, and at the beginning here we have here beginning solution is the same. Here is the same. We make this dictionary, but here we have make a vector from our dictionary and the string. This is the function here. Make a vector. So we go through our string, and if it's in the dictionary, we push back on the vector with a this letter and the index where this was before this this change. Okay, then we have this vector v, and we have also the same left, right. There's the same. The rest is the same, almost the same. So this is the same here. Here we have the while. Maybe I will expand it more. Okay, and the window. So here we take a character before, but from the window, from the first. So this is the letter, and we go to the add to our window, and we check, and then the same checking here. If this is required, here this is okay, but on here we have the answer. We have to, if we want to count how many letter is between these letters, between our end and begin our window, we have found also our vector, the right, and the second we take a second, so this will be the index of our letters. For example, this will be for index 0, so no, this is the right, so this will be for 5, and this our left, the second have index, for example, 0, so minus will be 5 plus 1, and this will be the size. And the same to our function, we get the index, so it's saved in our second second value in our pair, because as you have here a pair. Yes. Okay, and this will be the same. The complexity will be almost the same, but in special cases, so this will be the s plus t, and the complexity will be of s plus t, the size of the s plus t. So this is the good complexity in both cases, but in this case, in this solution, in one case it will be faster, it will be a lot of the letter that isn't in here, this will be a lot of, then this solution will be faster. Yes, and thank you for watching, and see you next time. Bye.